So today we are going to discuss about the relation and functions. This is the second chapter of the NCERT book, class 11. So relation and function you will be seeing from the entire syllabus. Like if you go to the differential equation, trigonometric functions, all are some kind of functions. So this is one of the building block of the functions. So yeah, let's jump into the topic.
So before we go into the functions, and this is a 2.2, section 2.2, and first I understand the Cartesian product. Cartesian product can be okay. Cartesian product of two sets A and B will be denoted as A cross B. Okay, and A cross B is a tuple form. Tuple form means A comma B. There will be a tuple form. So let's see. A is A equals to your A, B, C, and your B equals to 1, 2, 3, 4. Okay, so what are the elements of A cross B is a set of all elements A comma 1. One element from will be from A and one element from B. So such that all of the elements will be here, like A comma 2, C comma 1. Okay, all the elements will be there. How many elements will be there? So now question is how many elements will be there? So it's clear, like if this A set has a p number of elements and B set has a q number of elements, then A cross B will have p q elements. Yes. Okay, so that's the conclusion. Like if A has a q number of p number of, let's say, p number of elements, and B has a q number of elements, then we can say that conducts A cross B will be p times q. Now let's understand one thing. A cross B not equals to B cross A. See the elements. This is the elements on the top. The first element will come from A, but here the first element will come from B. So these two data sets are different. Okay, this is about the Cartesian product. Now let's jump into our second topic. Second topic is 2.3, which is relations. What is relation? Definition of relations is that for any set A and B, a relation is a subset of E cross B. Okay. So yeah, relation is like we have A cross B, a Cartesian product, and this will have how many number of elements? P cross Q. So you pick any subset of them. You pick any subset of them, that will become your relation. Okay, it's a very simple thing. So let's understand the now a domain. Okay, let's say we have A cross B. Let's give an example. We have A cross B, and like we pick A comma 1, B comma 3, C comma 2. This data set become, this is a relation. Okay, so here any subset means any non-empty subsets. Why non-empty? So empty sets does not, empty set is a subset of anything, but any sets that we are not considering that one here. So yeah, that's pretty much about relation. Now let's talk about a domain for relation. Domain, you have a relation R. Okay, R. Let's say this one is R. R is a relation. The set of all is the collection of first element of a relation. Set of all first element of a relation called your domain. So in this relation, what will be our domain? What are the collection of the all first element? First elements are A, B, and C. So this is become domain. What is codomain? Now let's talk about the codomain. Codomain are, it's a like for any relation uh, any possible set of for any relation there will be A and B. Okay, these two set will be there. The second set codomain is B. Okay, now let's talk about image uh, image of a function, image of a relation is the second element of a tuple. Let's say A. So let's give this example. So for A there is 1. For A comma 1, the image of A is equals to 1. Now let's talk about a different thing. So let's set r1 equals to A comma 1 and A comma 2. Two elements are there. Then your image of A equals to 1 and 2. Since both of them are in the tuple of A, so this is the thing. Now range is a set of all second tuple. Now let's think about, so all the second tuples will be coming from where? Will be coming from all the second tuple, second element of the tuple will came from B. So this range is always a subset of B. Okay, so what are the things we learned here? We learned about domain, which is set of all first element, set of all first element. Codomain, let's say range, set of all second element. Now the image, we also understand the range and codomain. Codomain is set of all or it's simply a B. Okay. Now here we have one question. So we understand the relation is for any subset of a Cartesian product is a relation. Now say how many. Okay. Now understand this question. Let's change a deeper color. How many relations possible for a Cartesian equals B. Okay, so these questions we'll answer this question. So this question is basically how we understand. So we A cross B have P comma Q elements. Let's rename those as a 1 2 times P comma Q. So this is a set. And how many non-empty or subsets are possible for this set? So this is the main question we need to answer. So let's say a relation R1. Let's R1 dash is a collection of all CBSE or subsets of A cross B such that it contain only so only one set, like there will be a P times Q number of elements in a set and we wanted to pick one of them. So how many choices are there? There are PQ number of elements and we need to choose one element. So there are total PQC1. C is a combination. Okay, so combination one, these many sets. So we can say that mod of R dash equals to PQC 1. Similarly, for two elements subset, we have PQC2. Since we need to choose two elements from the PQ, so the how we can do this, how many possible ways we can do this, PQC2 possible ways we can do this. So going to that, for the generalized I element, so there will be PQCI, total number of elements will be there. Now so then total how many number of possible choices we have? We have summation of I is equal to 1 to n PQCI number of total relation possible. Now this is a very familiar series. Okay, so what are the like if you 1 plus x to the power p cube equals to summation I is equal to 1 to n p q c I x to the power I. Okay, this is the series. Now if we replace x by 1, x equals to 1, then we will get 1 plus 1 to the power pq, which is summation I is equal to 1 to n pq ci, which is equals to 2 to the power pq. So in total there will be what's the mistake? In total there will be 2 to the power pq elements. Okay, so this is your 2.3 ends here. Let's talk about your 2.4.1. okay, 2.4.1, which is talking about the function. In this module we will talk about the function. Let's check the definition of the function. A relation will let's say from a to b called a function if for any element of a has one and only one image in. So this is a big thing. Let's break it down. Okay, it's saying that for any element of A, it will have a image in B. Okay, so it means first one, for all, this is a for all, this is a notation for all. For all A belongs to A, there will be a image in B. Okay, so one thing, if you remember the previous module, so then range of domain of A, domain of this relation R will be A in total. So domain is all the first element. All the first element will have a image. So this is a set, like the full element will be there. Now the second condition says that it will, for each element of A, it will have one and only image. So that means that A can go to only one element. Let's see the picture. What does it tell? Let's say this is A and this is your B. Okay, let's say A, this is B, this is C, this is your 1, this is 2, this is 3, this is 4. So first of all, it's saying that so each element of A will have an image in B. Okay, so for each element of A, there will be image in B. Now second thing is that for all element of A, there will be only one image in B. So this means that Is this relation possible? Like a is going to 1 and a is also going to 2. This is not a function. Okay. So but remember that this never restrict this picture. Okay. A, B, let's say 1, 2, 3, A, B, C. This never restrict this kind of picture. So one element in B can have multiple pre-image. Pre-image means corresponding to element in B, what is the element in A. So pre-image, like it's a subset of range. It's a set of range, and it may have multiple elements. Okay, this is the first function. Okay, now let's have a next one is the real valued function. Real valued function is this is a function from a subset of R real number to R. Okay, so we can denote this as a f such that like it's any subset, any kind of subsets to minus infinity to infinity. This is a function. Now let's see a image. Okay, tell me, giving one example, tell me if this is I'm giving one example, so tell me if this is a function or not. Okay, let's see. Okay, let's see this one. Okay, this is a kind of function which is y is equal to x square plus 1. Okay, so if x equals to 0, y will be so I'm giving the wrong one. So let's see, y square is equal to x plus 1. Okay, this is y square is equal to x plus 1. Is this a function or not? Is this a function or not? So first of all, this is y. First of all, for any element of x, not any element, so if x belongs to your minus 1 to infinity, close open interval, x belongs to x, it has two images. Okay, suppose let's say x equals to your 5. X equals to 5, then it will be have, if x equals to 5 comma 0, then it will be have 5 comma 2 and 5 comma minus 2. It has two elements. So but by the definition, so what is this? what is this? So here is 5 is there, and this is r, this is not r, so my minus 1 to infinity. 5 going to 2 elements, 2 and minus 2. This is not a function, not a function. Okay, we can end this class.